Now that we see the problem with manual testing, let's fix it by adding some automated tests. But before we jump into testing, I'd like to talk a little bit about the types of tests. For the most part, there are three types of tests: unit, integration, and end-to-end. You may hear people refer to these as feature tests, but for the most part, we'll talk about these three types of tests. Looking at the diagram, you can see that unit tests take up the largest chunk at the bottom. It signifies that the unit test should be the most in number, followed by integration tests, which are typically a lot fewer than unit tests, which test the interaction between different classes in your code, as opposed to a single method of a single class, like what unit tests do. Finally, end-to-end tests, which should be the fewest in number, as they usually are very slow to run and are flaky, as these tests test the behavior of the code as seen from an actual user. So what are unit tests then? Unit tests are ones that test a single function or a single method in a class or a property of an object. Each unit test tests some behavior of that unit. So a unit is just a function. Let's look at a very simple example. I'm going to create a calculator class in my source directory to show you what a unit test would look like. So say I have a calculator class, a very simple calculator class, equals class calculator, and it has an add method on it that takes any number of numbers and returns its sum. For a simple example, we'll just say numbers reduce, accumulate the sum and give me the current number, and we'll just say add the number to the sum and return that sum. So what would a unit test look like? A unit test is something that tests just this method. Let's go ahead and create a unit test for this class. So within my tests directory, I'll create a calculator.test.js file. Here, first I'm going to start off by importing expect from Chai. You don't have to really know this stuff. Just come along for the ride. And then I'll actually go ahead and import the calculator. It goes up one directory into source and calculator. Mocha provides us with a few higher level functions that allow us to format the output of our tests itself. So I'll say, I want to describe my calculator. And within the calculator class, I'd like to describe the add method. This is a matter of preference, the way you structure these tests. Mocha doesn't really enforce this structure. I just like to do it this way. As you will see soon in the output when we run the test, it actually looks very nice. So here I'm going to start writing down my expectations of how this class should behave. So I'm going to say it should return the sum of numbers. In this way, a unit test allows me to describe the behavior of that one method. You should ideally have these descriptions or titles as descriptive as possible, because they do allow for documentation down the road, either to your future self if you're a single member team, or to other members of your team. So they can come in here, look at the calculator tests, and immediately know what the calculator is supposed to do. So in this case, let's new up a calculator. Let's just call this calc. We want to test the add method, so let's call calc.add123 and store that in sum. And I'm going to say expect the sum dot to equal, this is all syntax that's given by Chai, it's there in the documentation, and I want this to equal 3 plus 2 plus 1, which is 6. So if I was to go ahead and run this test, let's see what that looks like. If I say npm run test, we can see that the add method actually completes and the sum of numbers. And this is what I mean by the output of the CLI. Mocha tells, all right, the calculator add method should return the sum of numbers, and this is super readable. Let's go ahead and create another test which exercises maybe a failure scenario. I really don't know how this calculator should perform if say there are no arguments given to the function itself. So I'm going to say if there are no arguments given to the add function, I'd assume that the sum is 0. So it should return 0 if no arguments are provided. And so I'll copy a bunch of this code. And here I'll just call add without any arguments, and I'll expect that the sum is equal to 0. And if we run the test again, you see that this test actually fails, which is great. So now we can actually go and fix this. So if we go back to the calculator class, we can say if the numbers dot length is 0, then we'll just return 0. And now if we test this again, it should pass. Great. So these two assertions actually pass. We'll just write one more test to show you what it looks like if a user provides bad input to the add function. So let's say the user says they want to add, one to, maybe you're getting this from a web form or something, and there's a malicious user that provides bad input. I don't know why you would have a calculator in a web form, but just say for this example, and they say ASDF as an input. Well, we don't really care about these values. We only care about the numeric values. So let's write a test that actually asserts this behavior. So it should return the sum of only numeric values and ignore non-numeric values. So you can see that I'm being very descriptive about the behavior itself. So if I was to paste this back and say 1, 2, 3 ASDF, and maybe even 1, 2, 3 as a string, or even 1 as a string, we want the sum to equal 6. So I'm going to expect the sum to equal 6. Let's run this. You see that one test fails, and it says expected 6 ASDF F1 to equal 6, because what's happening is that it's concatenating all of this and returning a string. So if we were to go back and modify this function, we'll say if type of num is number, then we'll return this. We'll actually add them up and return it. Or we can just say if the type of number is number, we'll add it up. Otherwise we don't do anything, and then we just return sum. Let's see if that fixes it. And that does. So we actually have written behavior for the add function with automated tests. Coming back to the diagram of the testing pyramid, the comparison between these types of tests goes further. Unit tests are really fast to run, as you just saw, as they don't really depend on things like an actual running database. But they do provide little confidence from an end-to-end perspective, or from the user's perspective. The trade-off there is that they help iterate on code very quickly by ensuring behavior isn't broken, and they help with narrowing down where a bug may lie. Integration tests, if you see from the diagram, are slightly slower to run, as they would actually need something like a database, but they do provide more confidence about the behavior of the system itself. Finally, end-to-end tests are the slowest to run. Like I said, end-to-end tests are an automated way of testing the interaction with the system, like how the user would see it. So this type of test uses a real database, a real cache, and maybe even reaches out to another service if you're using a microservice, for example. Because the number of dependencies for this type of test is high, they tend to be flaky, meaning they are more prone to failure. The advantage is that these tests give the most confidence about the system as a whole. The three types of tests together form a cohesive suite that allows us to confidently develop software, ensuring behavior doesn't break as our team grows and as business requirements change.